Hello students. Now today we will discuss the engineering physics syllabus module number 5 material science. In the material science we already know it will having a three parts. First one is the conductors, semiconductors and dielectrics. Out of three in this class we will discuss only with the conductors. In the conductors we need to study both classical free electron theory and quantum free electron theory. In the classical free electron theory it was given by Drude and Lorentz. Both the scientists, Drude and Lorentz, they came forward and give their ideas about the free electrons. Okay, both of them they gave their idea about the free electron. Hence, the theory they have considered as a Drude-Lorentz theory. Okay, after that, Drude-Lorentz they came forward. They have given the ideas based upon the assumptions they will consider. Okay, those are assumptions you need to study. After the assumptions, you need to study with the demerits of classical free electron theory or failures of the classical free electron theory. When we study the classical free electron theory, few of the drawbacks we are getting with the classical free electron theory. To overcome that one drawbacks, then the new theory we have considered, the theory is called as a quantum free electron theory. Now, in the quantum free electron theory, this was given by Arnold Sommerfeld in the year 1928. Okay, Arnold Sommerfeld, he has succeeded. What are the drawbacks we are getting in the classical free electron theory? Those drawbacks he has taken and he has overcoming the drawbacks, and the success he got it with the classical free electron theory. Okay, then the name he has considered as a quantum free electron theory. How he has succeeded means by considering the Pauli exclusion principle. Okay, base he has considered and few of the assumptions also he has taken. Okay, the assumptions he will consider as a quantum free electron theory assumptions, and the success also he will consider as a quantum free electron theory success. Those success and we will study with the in detail with the class. Okay, now we will study with the classical free electron theory assumptions. Okay, got it now? Classical free electron theory assumptions. This was given by Drude-Lorentz theory. The first assumption is a metal consists of a large number of free electrons and they move freely throughout the metal. Okay, here imagination is important here. Okay, for example, in a classroom, you just imagine the classroom is a one metal, and all sitting in the classroom, the students we will imagine we have considered as a free electrons. A metal consists of a large number of free electrons and they move freely throughout the metal. Within the classroom, all the students they can move freely. Okay, we need to comparison with classroom to the assumptions of the classical free electron theory. Next, second assumptions they have considered, the free electrons in a metal may be equivalent to gas molecules, and the kinetic energy of the gas molecule equals to 3/2 kT. Okay, normally only the gas molecule freely it will be moving anywhere. Now, inside the metal means in a classroom, the free electrons means the students they can travel freely. Okay, the students we will consider as free electrons, and the kinetic energy of the gas molecule we have considered here is the 3/2 kT. Next, third assumptions. Here K is a Boltzmann's constant and T is the absolute temperature. Now, the third assumption is the attraction between the electrons and the lattice ions and the repulsion between the electrons is insignificant, or we can neglect it or ignore. Is it clear now? That is the third assumption. And fourth assumption is the free electrons travel in a constant potential field. These are the four assumptions given by Drude and Lorentz, or these assumptions are also called as a Drude-Lorentz theory assumptions. Next, we will consider the what are the failures we will got it in the classical free electron theory. The first failure is specific heat. While we explaining the specific heat according to the experimental value and according to the classical free electron theory, both will be different values we will get. Okay, when both values we will get same, then only we can accept the success of classical free electron theory. But we are getting as a different value. Hence, this specific heat will be explaining the classical free electron theory. Okay, that one we will consider as a failure. Now, second failure we got it in the classical free electron theory is temperature dependence of electrical conductivity. And the third failure also we have considered in the classical free electron theory is electrical conductivity depends upon electron concentration. Now, all the three failures we have taken and we have succeeded in the quantum free electron theory while explaining. Okay, now assumptions of the quantum free electron theory. What are the assumptions of the quantum free electron theory? Means two of the assumptions they have considered with the classical, only two assumptions they have changed. Okay, Now, first one is the energy values of the conduction electrons are quantized. The allowed energy values are realized in terms of set of energy levels. We know that, okay, the energy levels, energy atoms will be in the energy levels only. Now, based upon the Pauli exclusion principle, Arnold Sommerfeld, he has considered the statement of the Pauli exclusion principle and he has made a one assumption. The distribution of electrons in the various allowed energy level as per the Pauli exclusion principle. The statement it will says that in one energy level, maximum of 2 electrons can be occupied. One is spin up, another one is a spin down, or plus of and minus of. These are the two assumptions he has made by Arnold Sommerfeld. Remaining two assumptions they are considered from the classical free electron theory. What are the two assumptions he has taken from the classical free electron theory is the free electrons travel in a constant potential field. That's the first one. And the remaining one is that the attraction between the free electrons and the repulsion between the conduction electrons is insignificant. These are the assumptions given by Arnold Sommerfeld. Two he has taken from the classical free electron theory. Only two assumptions he has changed. Okay. Now, after the assumptions, the success we need to study with the quantum free electron theory. Why we need to study here quantum free electron theory means success. While study the classical free electron theory failures, what and all failures we got it, the same failure we have taken here. Okay, was taken Arnold Sommerfeld and he has succeeded. First, he has succeeded while explaining the specific heat. See here, while explaining the specific heat, he has succeeded. Second one is the same temperature dependence of electrical conductivity. And third one is electrical conductivity depend upon electron concentration. Okay, all the three success we got it in the quantum free electron theory. Hence, this one we have considered as a success of quantum free electron theory. In detail, we will study with the classroom. Is it clear now?